Hello and welcome to this AQA Further Statistics video, Discrete Random Variables 2, the fourth in the series looking at the Poisson distribution. And this video is going to look at the mean and variance of the Poisson distribution. So with the Poisson distribution, there is a very particular relationship between the values of the mean and the variance. And if you're used to using GeoGebra, using the probability calculator to just investigate for some different values of lambda, the shapes, this is lambda equals 4 of the distribution, and also the output that you will get, which is for the mean for that distribution and the standard deviation for that distribution. And as we look at a few of these, hopefully you'll spot the relationship between the mean and the variance. Remember, the variance is just going to be the standard deviation squared and the value for lambda. So this time we're looking at a Poisson distribution where lambda is 9. And again, you can see the population mean there is 9, standard deviation is 3. And finally, if we look where lambda equals 16, you can see the population mean there is 16 and the standard deviation is 4. So I expect you can identify what you think that relationship is between the Poisson mean and the Poisson variance, and also lambda. And here we have explained that particular property of the Poisson distribution, quite an unusual property, that the mean and the variance of the population are both equal to the Poisson parameter lambda. And do bear in mind the fact that the variance equals lambda would imply that the standard deviation is the square root of lambda. And this particular property is very useful to use to check whether a particular set of observed data might be indicating that a Poisson model would fit that particular random variable. So if we look at an example here, we are certainly counting something. We're looking at the number of employees suffering an injury. We're looking at it within a defined time period, a week, and we have discrete outcomes here. So certainly the Poisson distribution would be one to consider to model this particular data. We now need to consider the conditions that we need for the Poisson distribution to see whether we think this model might work. And if we go through those conditions, it seems okay to assume, without any evidence to the contrary, that injuries occur singly, so they can be counted one by one. They also probably can be assumed to occur at random during the week. They occur independently of each other, and perhaps weekly over the year we could assume that they have a uniform constant average rate. And those four don't seem unreasonable assumptions, and therefore it looks like the number of employees injured in a week could be modelled with the Poisson distribution. So for further backup for this idea of a Poisson distribution being used to model this data, we can evaluate just from our sample data the mean and the variance, and remember that we would expect those two to be approximately equal to each other if a Poisson model was appropriate. And working that out, probably the best route would be just to put this data into your calculator and get the answers directly. But you have the summary data here and the mean and variance worked out for you. The mean, and remember this is a sample mean, it's not the population mean, but it's going to give us a a pretty good idea what the population mean might be. So we have the mean is 0.5 here. And then if we work out the sample variance, and remember your calculator will give you the sample standard deviation, not the sample variance, so you'd have to square that result. The sample variance here with this n-1 divisor, remember, because this is a sample, it's not a population, sample variance comes to be 0.49, and that is pretty well the same as the mean. So that gives further evidence that the Poisson distribution would be a good model for this particular data. And that concludes this final video looking at the Poisson distribution.